Hey, hello friends, and welcome to another video of the series. In this video series, we are making a full-fledged IoT board from scratch, and this is one of a kind video series available on YouTube where you are learning things from scratch to the advanced so that you can make a hardware like this. Here we are using ESP32 for the Wi-Fi and the BLE. We are using a host MCU from the ST microcontroller. We have the Quectel EC200U 4G LTE modem along with the GNSS so that you can have GPS coordinates. We have a micro SD card option as well so that you can log the data locally. We have an external SPI flash for the OTA, that means over the air upgrade on this hardware is possible. We have the interfaces or the communication interfaces done primarily CAN communication, and in this particular video we are going to talk about type C connector or particularly USB 2.0, how to make hardwares where you can use USB 2.0 communication. Either you can use this type C for powering your hardware or you can use this for flashing. So when it comes to ESP32, all the latest series of ESP32 supports USB 2.0. When it comes to ST microcontroller, there are few series where you have USB 2.0 supported. Even there are few series like STM32H7 series where you have the OTG support as well. That means you can use this as a device or a host. And for the Quectel EC200U, we are using a dedicated Type C connector with the USB 2.0 so that you can have the AT commands or the debug commands directly running, and even you can use the OpenMCU of this. So this video is going to be very interesting. So Altium is one of the most popular PCB design software. When it comes to Altium, you have few features which is not available in any other software, that is like Altium 365. In case of Altium 365, you can create a project, connect with your team across. So it takes from the requirement to the parts library, BOM management, schematic, board design, manufacturing portal. So if you see, right, you can have a collaboration done across all the teams, and the whole requirement, supply chain, library management, ECAD connectivity, co-design integration when you are working with multiple teams, multiple designers, and for the manufacturing. Even if you are a newbie, I would suggest to get a career start with Altium. I have provided a link in the description. You can check that link for the free trial. So here you can see the micro USB, which was the primitive sort of a connector which was available in most of the previous generation hardwares. And even if you would have worked with Arduino Nano, right, you had this micro USB. So the challenge with this sort of a connector was it is only one orientation. That means you can insert only one way. Okay. Whereas in case of USB port, now it is common with every devices which we use, be it your laptop, be it your charger, be it your monitor. So everywhere you are seeing a USB C connector. Okay, so I tried to just highlight the three main features of USB-C port or the C-type connector. So it has a flippable connector. That means you can, orientation doesn't matter. You can flip this and insert. It will work as is. It supports a USB 2.0, 3.0, 3.1 Gen 2 standards. So these are basically the standards of the USB, and USB-C supports all of these. Moreover, you have a third-party protocol, as I said, for your monitors and other things you would have seen, even the display ports that have a Type C option. Okay, it allows the device to negotiate and choose an appropriate level of power flow through the interface. So what does it mean? So you would have seen now you have chargers common for your laptop, common for your phone, okay, and even for your power banks. Okay, so how these things are working, these things are basically working based on the label shifting of power. Now this can be achieved with Type C, which we'll be seeing in the next slide. So if you see, right, this is the receptacle, and if I zoom it over here, right, you can see these are the copper contacts, right? So whenever you are putting your Type C connector, right, these makes a contacts. Okay, and if you see here, we have 12, on the other side we have 12. So this is what it looks like. And if you see, this is an inverted image, inverted mapping, I can say, inverted mirror mapping. So from here you have A1 goes to A12, then B1 goes to B12. So let's understand what all these are. Okay, so A1, B12. Okay, so if you see the matching, right, A1, B1. Okay, then TX plus, TX2 plus, TX minus 1, TX minus 2 minus. So these are basically, as I said, it's a inverted mirror. So doesn't matter. Whatever the direction you insert, always the contacts would be there, okay, with the same sort of an interface. Okay, so if we talk about A2, A3, A10, A11, right? So these are basically the super speed data path, which we are not currently using in our hardware because we are using USB 2.0, where this A6, A7, B7, B6, right? So these are the D plus, D minus, D minus, D plus. So these are the interfaces for our USB 2.0. When it comes to VBus, so these are the pins that basically powers our hardware. So if in case you want to use USB 2. Type C connected power hardware, then you have to rely on these pins. So this would be like 5 volt, then you convert with the help of LDO to 3.3 volt and then give it to your ESP. Okay. So again, we have this CC1, CC2. So these are basically for USB PD communication, where it basically have a detection mechanism, and this is basically drives in terms of appropriate level of power, right? So when you are connecting the same common charger to your laptop or to your phone, so how that current changes, right, is based on these selections. Okay, you have so there are other things also that goes around, but these are primarily for your USB PD communication. When it comes to SBU1, SBU2, so I have personally never used this. These are for the sideband use, and primarily these are getting used for your audio devices and all. Okay, so we will not be using this B8 and A8. Already I talked about this, and even in our hardware design, we'll be connecting this with the uh, pins of our ESP and the ST microcontroller and Quectel EC200U. When it comes to these also, right, so as I said, these are again mirrored, and these are for high speed data path, okay, which will be there in USB 3.0, 3.1. Okay, so this is all about the 24 pins. Okay, but the interesting part is when you design a hardware, right, you will get connectors. So these are the actual connectors or the PCB mount connectors, where you have a 6 pin option, 12 pin option, 16 pin option, 24 pin options, and this is how the footprint looks like. Okay, now how when to select these? Okay, so based on your application, you will be selecting whether to go with just the 6 pin interface, whether to go somewhere you want a 12 interface or a 16 interface, or go for a full-fledged USB type C connector, where you have all these 24 contacts available. Okay, so let's see one by one. So before starting, let's first see what are the different orientation and mounting options we get in Type C. So if you see here, right, this is a surface mount. Then this is where you have a cutout on the PCB and it mounts in between, right? So this is there. Then you have something where it is inverted and mounted, and it is been flushed with your top surface of the PCB. Then you have something that goes underneath. Then you have vertical mountings as well. So let's see some of the basically some of the parameters or the features of these connectors. So these are all the available parts. Okay, you can go to Mouser or DigiKey to search the appropriate part for yourself. But here, if you see, we have this USB 2.0 version. The number of contact is 16. It is a surface mount type, and then it's the voltage rating is 48 volt DC, and the current rating is 5 amps. So always you might not be getting connectors where the voltage rating is this. If in case you are making a low power system, always select something like 5 volt, 9 volt, or 12 volt rating, so that the cost is lower. Even the current rating, if you see, right, this is 5 amps. But for our hardware, when we see this hardware, right, so ESP32, if you go through the hardware requirement document, you have 500 milliamps as the bare minimum requirement. That means half ampere, zero point 0.5 ampere is what is required. So this becomes an overkill. So you have to justify basically on based on your requirement what part to select. And in terms of mating cycle, you have 20,000 mating cycle. That means the 20,000 times you can have an insertion operation without having any sort of a mechanical deterioration where it becomes loose or not supporting properly. So this is just I try to show you few of the basically parameters how to select. Let's go back to the slide again. So for a 6 pin USB type connector, right, if in case you just want power, Okay, you just want to power your hardware. So you can go with a 6 pin type, okay, where you can have the V bus and the ground connected. Even this CC which is there, right, you can have your D plus D minus. So even on a 6 pin, you will be able to support USB 2.0 power. Okay, so that is a possibility. So this is a cost effective for low speed or charging only application like basic power banks or simple microcontroller boards. When it comes to 12 and 16 pins, right, so these are more likely the same sort of a connector option. Okay, so if you see, we had this 24 contacts. Out of those, we have just removed the super speed pins. Okay, once you are get rid of super speed pins, you are left with the 16 pins, right? And sometimes these grounds, right, becomes a common shield mounting, so those won't be there, and that is where your 12 pin option comes. So here you have all the option for your VBus, for your USB 2.0. SBU we might not be using, but yeah, it would be there. Then you have CC1, CC2. So in most of the hardwares, even from the SparkFun, Adafruit, all these, if you see, right, they would have pulled down this with a 5.1 ohm resistor, which we'll see in the upcoming slides. So basically, it adds orientation support with better grounding or sideband communication, which we are not using. If in case you have a audio dongles or some sort of a mobile accessories, if you are using, your intent to make the hardware is that, then you can go with this. But for our hardware, we'll be going with a 16 pin or a 12 pin option. Now, if you see over here, right, 16 pin is generally the official name of the interface manufacturer and the package, while it customary to call it 12 pin in daily life. This is because when the interface is designed, the two V-bus and the ground outlets at both end of the Type C females are put together. So this is the reason, once you combine these, right, combine this V-bus and the ground, right, it becomes a 12 pin connector. Okay. Now, if in case you are interfacing with a ESP32 or a Quectel EC200 in a custom board, right, and want to use USB Type C, so what would be the ideal pinout option? Okay, so just for power, as we saw, you can go with a 6 pin type with where you have a very compact, minimal routing, good for low cost design, and it can give 5 volt to this, right? And then you need a LDO to basically convert that 5 volt to 3.3 for ESP, and for this you need to give 3.8. So already we discussed about the power requirement, or I can say the whole uh, step down and LDO in the previous video, so you can go and check those. In case you want power plus USB 2.0, this is what we are aiming for, then it's ideal to go for a 12 or a 16 pin option. Okay, and also you can have flashing done. Okay, so if in case you want to flash ESP32 over the USB, that can be achieved. Okay, pin option. In case, okay, if you want a full-fledged USB with power delivery, debug access for future expansion, which we are not doing, then you can go for a 24 pin Type C, which will be a overkill unless you are designing a very versatile dev board or planning for advanced USB feature like PD powered negotiation, USB to UART debug interfaces and all. Okay, so for us, we will be using a 12 pin and a 16 pin Type C, which is the best balance for our requirement because we want to have USB for flashing and powering. And when it comes to UART, right? So basically, when it comes to UART, sometimes we uh, misinterpret saying ki USB 2.0 and UART is same, but we'll see that like how those things are different. Let me go ahead with the next slide. So if in case you are designing a PCB with a USB Type C connector, especially for power and USB 2.0, it requires some attention to the electrical, mechanical, and signal integrity. So let's see what all checklists are there. So define the purpose of the USB port. Okay. So already we discussed. So you can basically pause and read this. Then it's a connector selection. So if you are using a 6 pin, 12 pin, what all uh, requirement based on uses would be. So this is a snapshot from the open source hardware design from SparkFun. If you see over here, right, you just have this 6 pin being mentioned where D plus D minus is there. Your CC1 and CC2 is been pulled down with a 5.1 ohm resistor, and then you have this shield which is being grounded, and obviously you have that ground pin. When it comes to USB 2.0 signal layout, right? So this is very important. So when you have your USB 2.0 signal line, right? So make sure you maintain a 90 ohm differential impedance. So these basically D plus D minus is differential pair where you have to make sure you have the impedance, right? The load impedance on that line is 90 ohms, not more than that. If you even if it is more than that, you will have things will work, but it will induce some sort of a noise, okay, and you will have a basically non-reliable communication. When it comes to length matching, so this is what differential pair we were talking about. That means it cannot be you can extend one D plus uh, straight like this and the other one like this, so both the path lengths are different, right? So that is not allowed. If in case you are doing it, you will not be having a proper signal integrity, okay. Avoid wires and sharp bend. So don't do wires. So I have seen people, right, they will just take it out here, then they will jump, go to the another layer or the ground layer, and then they will come over here, right? So avoid wires and sharp bends as much as possible. Don't use it. Route as a differential pair, as I said, okay. Keep trace width and spacing tuned to your stack up. So make sure whatever the spacings, right, there should not be a power line or things adjacent to that, okay, or very near to that, because that can induce some sort of a noise. In terms of CC configuration or the pin handling, so as we saw, right, we have to have a sync mechanism where basically we are syncing it or pulling it down with a 5.1 kilo ohm resistor to the ground. It helps the source detect as a sink and supply 5 voltage, since it's a low power device where we are putting the 5-volt supply, right? So this is must that needs to be done. And in terms of dual role or a PD controller, which is optional, right? So sometimes you can use Type C controller ICs like these, okay, to negotiate in terms of voltage, roles, and current limits. So this is not required for our application. If in case you want to understand more about this, you can basically go through the data sheet of these parts. And let's go to the next slide. So power input consideration. So based on, as I said, right, ESP32 takes around 500 milliamps, right? So you make sure you have that, whatever the connector you are choosing, right, it should have that rating in place, okay, or up to 3 amps with a Type C resistor. So EC200U, right? The maximum current it can take, right? Momentary current it is 3 amps. So whatever you are taking, right? So you can have both the parts if you want to make common. You can go with something that supports 3 amps so that you are covered for EC200U or the Quectel 4G modem, and also for your host MCU and the ESP32, and adding a TVS diode for VBus ESD protection. So this we'll see in the next slide. Okay, let me go through few of the open source schematic so that you can understand all those things. When it comes to ESD and EMI protection, so we can have the ESD diodes done on the D plus D minus line, and on the VBus also you can put that, and you can have a common mode choke if the EMI filtering is needed. So in any sort of a radio circuits and other things you have, right, so you need some sort of electromagnetic filtering, okay, so that you need to have in place. So let me show you few of the open source design. So this is Adafruit feather series, right, and this is on STM32F40, okay, and this has been connected to USB. So let me just find, okay, so here we have this USB pin, right, and you can see D plus D minus, CC1 CC2, then S bus is not connected, okay, and if you see CC1 CC2, right, it has been pulled down so that it syncs, okay. And in all the hardwares, even if any of these hardwares, if you go, right, all these are open source hardwares from the Adafruit or the SparkFun, you will have that in place. So here if you see the D plus D minus is directly connected over here. So these, if you go through the pinouts, right, you will see these are the USB D plus and D minus for this ST microcontroller. Let's see another one. So this is again from Adafruit, and here let's see the USB C section where it is. You can see the USB DP, which is the D plus, DN is D minus being connected. Then CC line, CC1 and CC2, right? If you see, it's been pulled down. So if you see, right, USB DN and DP, right, you have this 10 ohm resistor. Okay, somewhere you will find this 22 ohm resistor also. This has been done to match the impedance. So in case you want this, you can put this in. I have mostly seen for any sort of a ST microcontroller, you have this. See here, right? So first of all, let's first see what is the UART and USB, right? So in UART, if you see, this is you have the USB DP and DN. In case of this, I think this has been inverted. Okay, so this one is USB and this one is UART. So here you have the GPIO 12 and GPIO 13, right? This will be TX and RX. So basically, in case of UART, you have the maximum throughput you can get, right? So you would have seen this baud rate, and we set that baud rate 9600, 11500, and it goes upward of 1 Mbps. Whereas in case of USB, this can go up to, for ESP32, it can go for 12 Mbps. Okay, so this is a high speed bus line when it compared to a UART. So in terms of interfaces, UART and USB are totally different. And here you have all this uh, EMI ESD filtering. Okay, then you have this protection diode that basically, since here you have external 5-volt supply coming in, right? So this will make sure there is no reverse current path. Okay, and this has been again decoupled with a 10 microfarad. So all these concepts of capacitors already we have seen in the previous video. You can switch and watch that. If we see this, so this is Think Plus from SparkFun. Here also they have the same thing. The CC1, CC2 is been pulled down to 5.1 kilo ohm, and USB P and USB N is directly connected over here. Okay, which is the D minus and D plus. Now, if you see over here, right, you don't have anything like a 10 ohm or 22 ohm connected on the D plus D minus line. But what I would say, right, it's always better to have this in place. This, if you see, this is a STM32 board from SparkFun, and here you have this 22 ohm resistor. If in case you are not using, you can put a 0 ohm resistor. And yeah, so this is all about this video. Okay, I'll be sharing this presentation in the description link. You can go and download it. And if you watch till this end and like this video, please share it to your friends. I'm making a lot of effort to make sure this video and this series becomes successful and you are able to learn things. Thank you guys. Thanks for watching. See you in the next video.